Good morning, dear students. Today, in this video, that is video number 11, part 2, chapter 3, force and pressure. We will start with the next topic, that is turning effect of a force. In the last video, we have done what is force and its SI units, its gravitational units. What today we will do the turning effect of a force. In order to understand this topic, I will take one or two examples. First of all, this is a smooth surface and a body is lying on it. And when the force is applied on it, the body moves in the direction of the force applied. Point is clear? Now, it means that when the force is applied on the body, it can bring a linear motion in it. Linear means straight line, one-dimensional motion. The body moves in the direction of the force applied. So this motion is known as linear motion. What if the body is pivoted at a point? Pivoted means fixed at a point. Like you just take one. This is a rigid bar, and let it is pivoted at this point. Pivoted means fixed point on which the body can rotate. Once again, students, this is also known as point of axis or axis of rotation. And even it is known as pivoted point. What it is known as? Pivoted point or fixed point on which this rigid bar can rotate. Now you see, in the first case we have applied the force and the body moves in the direction of the force applied, and it can bring the motion in the body, and that motion is known as linear motion. Now students, this is a pivoted point, fixed point. If I will apply a force on one end of the bar here, what will happen? I am applying a force in the vertically upward direction. Point is clear. Now what will happen? It will start moving like this. Isn't it? Means it will start moving like this. Means anti-clockwise. What if you will apply a force on this end? This end. Now what will happen? It will start moving in the upward direction. Now it will move in the clockwise direction. It will move like this, clockwise direction. So it means that when the force is applied on the pivoted body, the force can bring a rotatory motion in it. It can bring a motion anti-clockwise depending upon the direction of the force applied, and it can bring a clockwise motion in the pivoted body. Now when in physics, when anti-clockwise moments or anti-clockwise rotation, anti-clockwise moments, that is taken as positive. positive. Clear? And clockwise moments or rotation, that is taken as negative. This you have to keep in mind. Even you can take a case of steering wheel. You can take a case of steering wheel. It is just like this. Steering wheel of a car. Now it depends in which direction you are applying. Even you can rotate it in this direction, or even you can rotate it in this direction. You can rotate it clockwise, or even you can rotate it in the direction of anti-clockwise. Mean depending upon the force applied, in which direction you are applying the force. So this is what turning effect is. Now the turning effects depending upon the two factors. Turning effect of a force depends on two factors. Means it depends on two factors. When you bring a rotatory motion in a body, only two factors are responsible for the rotatory motion. The first factor is the magnitude of the force applied. The magnitude of the force applied. Then the next is the perpendicular distance. The perpendicular distance of the force from the axis of rotation. From the axis of rotation. So these are the two factors. So let us try to understand this. Once again, you can take one rigid bar. It is pivoted at this point. Clear? Now you are applying a force on it. Let the force applied is 5 Newton. Now this 5 Newton is the magnitude of the force applied. Means how much force you are applying. So this is 5 Newton is called the magnitude of force. Now the next is the perpendicular distance of the force from the axis of rotation. Now this is the pivoted point, this is the axis of rotation. Now from the pivoted point, the distance at which the force is applied. Now this perpendicular distance, it is taken as r, and let this is 5 meter. This perpendicular distance. So these two factors are responsible for the turning effect of a rigid body. I think point is clear to you. There are so many examples given in your book, bicycles and all that we will discuss later on. Now let us move to the next topic, that is moment of force. Next topic is moment of force. This is the next topic. Now, moment of force, we can define it from here, from these examples only. Moment of force, it is also known as torque. T-O-R-Q-U-E. This is also known as torque. This is equal to force, means the magnitude of the force. Second is perpendicular. I am just taking the symbol of perpendicular. Perpendicular, this perpendicular distance. Perpendicular distance from the axis of rotation. In short form, we can write F into R, perpendicular distance. Clear? This is your F, magnitude, and this is the perpendicular distance. This is your F and this is the perpendicular distance. Even you can calculate the moment of force from here. Like force, we are applying 5 Newton and the perpendicular distance is 5 meter. So what is the moment of force? 5 into 5, this is 25 Newton meter. Clear? In other words, you can say that the SI unit of moment of force is SI unit of moment of force, important point, is Newton meter, Nm. N is the SI unit of force and M is the SI unit of distance, that is meter. So Newton meter is the SI unit of moment of force. Now CGS unit of moment of force. CGS means centimeter, gram, second. Unit of moment of force is, that is dyne into centimeter. Dyne centimeter. That is the CGS unit of moment of force. Gravitational unit, even you can write gravitational unit. Gravitational units, that is GF centimeter, gram force centimeter. GF means gram force centimeter and kgf, kilogram force. These are the gravitational unit of moment of force. Once again, students, this is gram force centimeter, this is kilogram force. Now, the relation between these units, Now the relation between this 1 Newton meter is equal to 10 raised to power 7 dyne centimeter. And then 1 kgf meter is equal to 9.8 Newton meter. And 1 GF centimeter is equal to 989 centimeter. So for the UT or a term exam, you have to learn this. Once again, 1 Newton meter is equal to 10 raised power 7 9 centimeter. 1 kgf meter is equal to 9.8 Newton meter, and 1 gf centimeter is equal to 989 centimeter. Now, some examples are given of turning effect. I will discuss only one with you. Rest you can go through of your own. Like, look, this is a spanner, and this spanner is used to open or tightening the nut. Just see to it. It has 2 jars. Okay, when you want to open the nut or tightening the nut, just see the handle is longer handle. It has a long handle. Long handle means if the perpendicular distance is more, the turning effect will also be more, and you have to apply less force. Just mind it, students, what I am telling to you. This spanner has a long handle. It has a logic behind it. Long handle means the perpendicular distance is more. When the perpendicular distance is more, the turning effect will also more. It means that the body will rotate more, and you have to apply less force. What if the handle is small? The turning effect will also small. What you have to apply large force. So this is the point which you have to keep in mind. So with this topic is finished. So let us start with next topic, that is pressure. Pressure. Now, pressure is equal to thrust upon area. Even you can write it in a short form. P is equal to T upon A. Pressure is equal to thrust upon area. Now the question is, what is thrust? Thrust is a force only. Students, what happened? Let this is a body. Clear? Now we can apply a force on it from anywhere. We can apply a force on it like this, like this, like this, like this, like this, like this, like this. From all the sides we are just applying a force on it. But when we will apply a force on this body normally, like this, means at an angle of 90 degree, normally or perpendicularly. When the force is applied on the body normally or perpendicularly, at that time that force is known as thrust. What it is known as? Thrust. So pressure is equal to thrust upon area. Now what is the unit of pressure? We can derive from here. Thrust is a force. And what is the unit of force? That is Newton. Area is meter square. So Newton per meter square is the SI unit of pressure. Even you can write it like this, Newton per meter square. So this unit, this Newton per meter square, is also called Pascal. This is also called Pascal. P small ASCAL, and it is represented with letter P A, Pascal. So 1 Pascal is equal to 1 Newton upon 1 meter square. Even we can write it like this. 1 Pascal is the SI unit of pressure. 1 Newton, that is the SI unit of thrust. 1 meter square, that is the SI unit of area. So that's all for today. Thank you very much.